Hey guys, welcome to another video. So today we continue on with the nice question series. Today's question comes from the Extension 1 syllabus in the topic of vectors. So it's a vector proof question. Now, for those that know, the vectors topic has not been part of the New South Wales syllabus for too long, started in 2020 when the changes to the syllabus came about. So today's question actually comes from the Victorian syllabus, where they've had vectors for quite a while. So it's a question from the NEAP independent papers from 2006. Now, before I dive in, if you haven't already done so, like the video, subscribe to the channel, and tell your friends. All right, guys, let's jump right in. So today's question isn't hard, but it's nice. And I've seen it already in New South Wales being recycled in a few past papers. So common question, make sure you know how to do it. Now, let's give it a read. So now, these Victorian questions, for some reason, maybe because they're more mature about it, right? There's actually quite a number of parts. In New South Wales, I found that there's less parts and probably more marks, so less guidance. These ones are, it tells a nice story in a number of parts. Let's have a look at the question. So OABC is a parallelogram, okay. Good to know. OA is A, OC is B, okay. Normally I would call it C, but okay. And magnitude equals to 2 times magnitude A, angle between, okay, cool, alpha, I can see that, cool. So what are my questions? So very quickly, dot product, I mean, I'm assuming that's simple. Yeah, it should be quite simple. Very, okay, cool. Now, what's this part? Let M be point here, okay. So that AM is MB, okay, cool. Let M is, yeah, it's a fraction, yeah. And that's a right angle, perfect. Okay, yep, sorry, I'll do everything given in blue. Okay, it's given. Okay. And my questions here are write down OM. Okay. MC, show this. Okay, might be hopefully not too bad. Show this state position. Okay. And find the set of values of our alpha. Okay, 2 possible. Okay. All right, let's dive right in. Doesn't seem too bad. All right, let's see. So first part, show that A dot B is that. Now we know that if this vector here was A, and this vector here was B. No, yes, B. Yeah. And the magnitude is equal to. Now, the notation here is actually quite important. See how they did A there? I suspect A in this notation here is just the magnitude of, is the magnitude, right? A without the squiggle, right? Yeah, let me just check. Yep, cool. That's what they call it. Or did I actually say anything? No. Yeah, so just notationally, if it's A without the squiggle, it's just the magnitude. It's the value of the magnitude, right? So for part A, yeah, all we need to do is that we know that cos alpha equals to A dot B, yeah, over magnitude of A times magnitude of B, right? Pretty easy. Guys, they want to make A dot B the subject, so do that please. A dot B equals to magnitude of A, magnitude of B, cos alpha. And then we sub this guy into here, right? And then you get that equals to A times 2 of these A's cos alpha. And then, like I said, guys, all right, replace magnitude with A. And so this guy and this guy are both A's, right? So then it becomes, therefore, possibly for 1 mark. Yeah, that guy equals to 2A squared, A squared being a constant, right? Yeah. Done. Part A, quite simple, quite straightforward. Part B, OM. Now, where's OM? So OM is there, right? And I already know from the given that AM is equal to MB, right? And we knew from part A that this guy here is A. So I'm assuming it's OM equals to OA plus AM. Okay, this looks like a freebie mark. So it's A plus MB. Check that. Okay, nothing too hard about that. Box around that. Feel like it's taking us somewhere, right? Now, MC. So MC, this one here. Now, there's a couple of ways to do this, but the way that I can see, right, is we're going to use this quadrilateral here, right? 1, 2, 3, 4, and sort of connect it, because I know, right, from the upstairs as well, that this is B. So I can go backwards on the blue, backwards on OA, and then plus B, and that equals to C, right? So I can say MC equals to, backwards on the blue, so MA plus AO plus OC, right? Yeah. And so backwards on that, that's negative MB. Backwards on the A, and then plus B. Yeah. Now what they asking me to do? So they just factorize, they rearrange it. So therefore, MC equals to, what did they do? They factorize 1 minus M, perfect, B, and minus A. Okay, good. Yeah, so what have we done so far? We've done that, we've done that. Now, show this guy, guys, feels like I need to connect them, right? So let's see, feels like for part D, I'm going to go OM, MC, this triangle, right? And connect them and see where it takes me, yeah? See where it takes me, let's see. So part D. So OA, let's see, OM plus MC equals to OC, right? So OC equals to, oh, actually no, part D. Because if you do that, where did the dot, say, actually, I think the key here is this dot product. Where did that dot product come from? Now, I can either do that triangle, maybe I'll use that triangle later. I haven't used a right angle yet, right? You haven't used a right angle, so let's go. OM is perpendicular to, okay, let's use a dot product. Yeah, that makes sense as well, because they basically, in the two parts before it, it's like a journey, right? They've taken us to OM, prove that, taken us to MC, prove that, and now, of course, then the dot product sort of makes sense as the next question equals 0. So now dot product between these two looks like a bit of a algebraic nightmare, but let's see, right? Plus MB dot with MC, which is 1 minus MB minus A, right, equals 0. All right, oh, too far. I think it's just expanding, right? Is that right? Yeah, just expanding. Jeez. Okay, bit of rainbows. That guy. This guy. This guy. Let's see. So it'd be 1 minus M A dot B. Is that looking? Yeah, it looks like good. Minus A dot A, so that's magnitude of A squared. And then plus M times 1 minus M B dot B. So magnitude of B squared. And then minus M times A dot B equals 0. Now, a couple of things, right? First thing is, I know that that and that can be replaced with A. So that guy there is A squared, and this guy here is 2A all squared, which is 4A squared, right? Let me see, is that what I want? Let's see, 2M squared, okay. Okay. Oh, no, maybe. Oops. Oh, well, I'm out of vertical space, okay. Now what I'm going to do, just going to move part D up here. I've got infinite space, why would I? This question, okay. Now, keeping one eye on the thing after proof, I think it might be okay now. So I'm gonna see this a plus b, sorry, a dot b. If I factorize it, it becomes 1 minus 2m, right? Yeah. So if you factorize the a dot, you get 1 minus 2m, which is exactly what the question asks for. And here, if I go minus a squared plus, what's that, 4? m 1 minus m a squared. I have a feeling, guys, that if you factorized a squared from that, you should get a perfect square, which is exactly what they want me to do. So let's see. This bit's done. Right, that bit's done. Factorize a negative a squared out. I get 1. And then because I'm factorizing as a negative, that would be minus 4m 1 minus m. Now, just very quickly looking at inside this here, I'm hoping it's a perfect square. Let's see, right? 1 minus 4m plus perfect, right? So that equals to 1 minus 2m all squared. Exactly what I want. Therefore, 1 minus 2m a dot b minus a squared. That's what I want. Nice. Quick look. Yeah. Perfect. Yeah, exactly what I want there. Now, by solving this equation, show that, right? Solving this equation. Now, okay. How do I solve it? Maybe factorize 1 minus 2m out, right? Okay, I've got my dot product from upstairs, so I'm going to sub that in as well. So here's what I'm going to do, right? I'm going to sub this guy into, sub that into here, right? Into the dot product, right? And then try to solve it. Let's see where that takes me. So this is for question E, right? Zooming in, question E. Sub it in and you get 1 minus 2m times 2a cos, no, a squared, wasn't it? Yep, alpha minus a squared 1 minus 2m squared equals 0. Maybe I'll factorize one of these brackets out. Right, factorize one of these brackets out. And maybe the a squared as well. Factorize a squared out. So a squared 1 minus 2m. Right, that's gone. So it'd be 2 cos alpha. Yeah, minus, so 2 cos alpha minus, that's gone, and then it'll be like 1 minus 2m. Yeah, now what am I solving for? M, right? M is a variable. Okay, cool. Yeah, show that M. Okay, so constant goes away, right? So then with this bracket, yeah, and this bracket, right? Okay, 2 separate solutions. This one here, M is clearly a half. Yeah, comma. And then what's this? 2 cos alpha minus 1 minus 2m equals 0. 2 cos alpha equals to 1 minus 2m. 2m equals to 1 minus 2 cos alpha. Therefore, m equals to half minus cos alpha. Is that what I want? Half, perfect. Half, comma, half minus cos alpha. Yeah, now, I've run out of space, so I'm just gonna copy this over the next page. Let's remove all this. Okay. I'll zoom in. Now, what's my next question is asking? State the position of m when m equals a half. Guys, that's really easy. That's a 1 marker, right? Because if you think about it, what is m? M is the ratio of this point, right, to basically tell you where it is on the line. So if that's a half, then it's a midpoint. That's all they're asking for, I think, right? So for part F, yeah, when m equals to a half. M is the midpoint of AB. Yeah, that's all they are, all they want. Yeah. Then what's G asking? Find the sets of values for alpha when there are two solutions. Now, we can see from here, sorry, don't need to scroll back. We can see from part E that there were, generally speaking, there's always two solutions, right? M equals a half and this. We want to now sort of express alpha to the domain where there's two solutions, taking into account that within that range, we can't have an answer equal to a half, because then there's only one solution, right? Because we know right now the answer is a half or something else. We don't want that something else to be a half, because then there's only one unique solution, right? So I'll tell you what I'm trying to do. So I know that, right, from this bit here, right? So from this bit here, let's see this bit here. I'll start there. M is between 0 and 1, right? So I'm going to plug this value here of M into here, right? So then it goes 0, so it's then equal to half minus cos alpha, 1. Now, minus half to both sides, minus half, that's then equal to minus cos, that's then equal to half. Divide by negative, so it becomes cos alpha, or the signs flip, yes, so it's the same. So it goes like, if you had to do it greater than half, greater than negative half, which basically means negative half. So technically, the negative just goes away. Right? Now, once you get there, right, that's basically saying that, right, alpha, right, to be, I mean, if you think about the cos graph, right, just to really think about where this solution is, right? What's the cos graph look like? Cos graph looks like, now where's plus and minus half? So normally this is 1, is negative 1, this is 1 equals to cos x, right? So half is there, and negative half is there. Yeah. Now, in this triangle, we know that the angle of alpha is that it can't be bigger than 180, right? So in this case, can't be bigger than, where's 180? 180 pi is there. So for it to be within the range, it has to be there and there, right? Yeah, so I sub in a half, sub in negative half. Now, people would know that when I sub in, this is positive half, by the way, in negative half. So for this solution here, that's when cos alpha equals to a half. So alpha equals to what? 60, so pi on 3. And for this one here, cos alpha equals to negative a half. Now, normally with all station central, you should get two answers, like 180 minus 60, 180 plus, but I don't want it bigger than 180, so it's just 180 minus, so 120, so that's what, 2 pi on 3. So for this answer, right, to solve it, you basically go, therefore alpha is between pi on 3, 60 degrees, and 120, right? So just to be clear, it's because it will need to be within this range here, right? Yeah, between a half and negative half and less than 180. So yeah, that's my answer. So if alpha was within that range, I'll get another answer. But what's important is, now I already know since pi on 2, yeah, since since when alpha equals to pi on 2, right? I already know that there's a solution, right? I can't have it this only, right, has one solution, right? Therefore, yeah, your range is pi on 3 less than equal to alpha less than equal to 2 pi on 3, where pi on 2, or sorry, alpha cannot equal to pi on 2, right? Yeah, because I want two answers. I don't want one, right? So within that range, 90 degrees is there, but I can't have 90 degrees, right? Otherwise, it's only going to give me one solution. For two answers, That's how you do it. Guys, that's a nice question. Hopefully that was all right. Like that, like the video, subscribe to your channel, and I'll see you at the next one. Cheers. Thank you.